for exploring. They have different needs and different goals. But no matter what you're doing, be clear in your graphics and be focused in what you're trying to tell. And above all, create a strong narrative that gives a different level of perspective and answers questions as you go to anticipate a client's questions and to give them the most reliable, solid information and the greatest confidence in your analysis. The final element of data science and communicating that I wanted to talk about is reproducible research. And you can think of it as this idea. You want to be able to play that song again. And the reason for that is data science projects are rarely one and done. Rather, they tend to be incremental, they tend to be cumulative, and they tend to adapt to the circumstances that they're working in. So one of the important things here, probably if you want to summarize it very briefly, is this: show your work. There's a few reasons for this. You may have to revise your research at a later date, your own analyses. You may be doing another project and you want to borrow something from previous studies. More likely, you'll have to hand it off to somebody else at a future point, and they're going to have to be able to understand what you did. And then there's the very significant issue in both scientific and economic research of accountability. You have to be able to show that you did things in a responsible way and that your conclusions are justified. That's for clients, funding agencies, regulators, academic reviewers, any number of people. Now, you may be familiar with the concept of open data, but you may be less familiar with the concept of open data science, and that's more than open data. So for instance, I'll just let you know that there is something called the Open Data Science Conference at odsc.com, and it meets 3 times a year in different places. And this is entirely, of course, devoted to open data science, using both open data, but making the methods transparent to people around them. One thing that can make this really simple is something called the Open Science Framework, which is at osf.io. It's a way of sharing your data and your research with an annotation of how you got through the whole thing with other people. It makes the research transparent, which is what we need. One of my professional organizations, the Association for Psychological Science, has a major initiative on this called Open Practices, where they are strongly encouraging people to share their data as much as is ethically permissible and to absolutely share their methods before they even conduct the study as a way of getting rigorous intellectual honesty and accountability. Now, another step in all of this is to archive your data, make that information available, put it on the shelf. And what you want to do here is you want to archive all of your data sets, both the totally raw before you did anything with a data set and every step in process until your final clean data set. Along with that, you want to archive all of the code that you used to process and analyze the data. If you used a programming language like R or Python, that's really simple. If you used a program like SPSS, you need to save the syntax files, and then it can be done that way. And again, no matter what, make sure to comment liberally and explain yourself. Now, part of that is you need to be able to explain your process, because you're not just this lone person sitting on the sofa working by yourself. You're with other people, and you need to explain why you did it the way that you did. You need to explain the choices, the consequences of those choices, the times that you had to backtrack and try it over again. This all also works into the principle of future-proofing your work. You want to do a few things here. Number one, the data. You want to store the data in non-proprietary formats like a CSV or comma-separated values file, because anything could read CSV files. If you stored it in the proprietary SPSS.save format, you might be in a lot of trouble when somebody tries to use it later and they can't open it. Also, there's storage. You want to place all of your files in a secure, accessible location, like GitHub. It's probably one of the best choices. And then the code, you may want to use something like a dependency management package, like PackRat for R or virtual environment for Python, as a way of making sure that the packages that you use, that there are always versions that work, because sometimes things get updated and it gets broken. This is a way of making sure that the system that you have will always work. Overall, you can think of this too. You want to explain yourself, and a neat way to do that is to put your narrative in a notebook. Now, you can have a physical lab book, but you can also do digital books. A really common one, especially if you're using Python, is Jupyter with a Y there in the middle. The Jupyter notebooks are interactive notebooks. So here's a screenshot of a very simple one I made in Python. And you have titles, you have text, you have the graphics. If you're working in R, you can do this through something called R Markdown, which works in the same way. You do it in RStudio, use Markdown, and you can annotate the whole thing. Get more information about that at rmarkdown.rstudio.com. And so, for instance, here's an R analysis I did, and you see the code on the left and you see the Markdown version on the right. What's neat about this is that this little bit of code here, this title and this text and this little bit of R code then is displayed as this formatted heading, as this formatted text, and this turns into the entire R output right there. It's a great way to do things. And then if you do R Markdown, you actually have the option of uploading the document into something called RPubs. And that's an online document that can be made accessible to anybody. Here's the same document. And if you want to go see it, you can go to this address. It's kind of long, so I'm going to let you write that one down yourself. But in sum, here's what we have. You want to do your work and archive the information in a way that supports collaboration. Explain your choices, say what you did, show how you did it. This allows you to future-proof your work so that it will work in other situations and for other people. And as much as possible, no matter how you do it, make sure to share your narrative so people understand your process and they can see that your conclusions are justifiable, strong, and reliable. Now, something that I've mentioned several times when talking about data science, and I'll do it again in this conclusion, is that it's important to give people next steps. So I'm going to do that for you right now. If you're wondering what to do after having watched this very general overview course, I can give you a few ideas. Number one, maybe you want to start trying to do some coding in R or Python. We have courses for those. You might want to try doing some data visualization, one of the most important things that you can do. You may want to brush up on statistics and maybe some math that goes along with it. And you may want to try your hand at machine learning. All of these will get you up and rolling in the practice of data science. You can also try looking at data sourcing, find the information that you're going to do. But no matter what happens, try to keep it in context. So for instance, data science can be applied to marketing and sports and health and education and the arts and really a huge number of other things. And we will have courses here at datalab.cc that talk about all of those. You may also want to start getting involved in the community of data science. One of the best conferences that you can go to is O'Reilly Strata, which meets several times a year around the globe. There's also Predictive Analytics World, again, several times a year around the world. Then there's much smaller conferences. I love Tapestry, or tapestryconference.com, which is about storytelling in data science. And Extract, a one-day conference about data stories that's put on by Import.io, one of the great data sourcing applications that's available for scraping web data. If you want to start working with actual data, a great choice is to go to Kaggle.com. And they sponsor data science competitions, which actually have cash rewards, but there's also wonderful data sets you can work with there to find out how they work and compare your results to those of other people. And once you're feeling comfortable with that, you may actually try turning around and doing some service. Datakind.org is the premier organization for data science as humanitarian service. They do major projects around the world. I love their examples. There are other things you can do. There's an annual event called Do Good Data. And then datalab.cc will be sponsoring twice a year Data Lab charrettes, which are opportunities for people in the Utah area to work with local nonprofits on their data. But above all of this, I want you to remember this one thing. Data science is fundamentally democratic. It's something that everybody needs to learn to do in some way, shape, or form. The ability to work with data is a fundamental ability, and everybody would be better off by learning to work with data intelligently and sensitively. Or to put it another way, data science needs you. Thanks so much for joining me for this introductory course. I hope it's been good, and I look forward to seeing you in the other courses here at datalab.cc. Welcome to Data Sourcing. I'm Barton Poulsen, and in this course, we're going to talk about data opus, or That's Latin for data needed. The idea here is that no data science, and that is a sad thing. So instead of leaving it at that, we're going to use this course to talk about methods for measuring and evaluating data, and methods for accessing existing data, and even methods for creating new custom data. Take those together, and it's a happy situation. At the same time, we'll do all of this still at an accessible, conceptual, and non-technical level, because the technical hands-on stuff will happen in later other courses. But for now, let's talk data. For data sourcing, the first thing we want to talk about is measurement. And within that category, we're going to talk about metrics. The idea here is that you actually need to know what your target is if you want to have a chance to hit it. There's a few particular reasons for this. First off, data science is action-oriented. The goal is to do something as opposed to simply understand something, which I say as an academic practitioner. Also, your goal needs to be explicit, and that's important because the goals can guide your effort. So you want to say exactly what you're trying to accomplish so you know when you get there. Also, goals exist for the benefit of the client because they can prevent frustration. They know what you're working on. They know what you have to do to get there. And finally, the goals and the metrics exist for the benefit of the analyst because they help you use your time well. You know when you're done, you know when you can move ahead with something. And that makes everything a little more efficient and a little more productive. Now, when we talk about this, the first thing you want to do is try to define success in your particular project or domain. Depending on where you are in commerce, that can include things like sales or click-through rates or new customers. In education, it can include scores on tests. It can include graduation rates or retention. In government, it can include things like housing and jobs. In research, it can include the ability to serve the people that you're trying to better understand. So whatever domain you're in, there will be different standards for success, and you're going to need to know what applies in your domain. Next are specific metrics or ways of measuring. Now, again, there are a few different categories here. There are business metrics. There are key performance indicators or KPIs. There are SMART goals. That's an acronym. And there's also the issue of having multiple goals. I'll talk about each of those for just a second now. First off, let's talk about business metrics. If you're in the commercial world, there are some common ways of measuring success. A very obvious one is sales revenue. Are you making more money? Are you moving the merchandise? Are you getting sales? Also, there's the issue of leads generated, new customers or new potential customers, because that then in turn is associated with future sales. There's also the issue of customer value or lifetime customer value. So you may have a small number of customers, but they all have a lot of revenue, and you can use that to really predict the overall profitability of your current system. And then there's churn rate, which has to do with losing and gaining new customers and having a lot of turnover. So any of these are potential ways of defining success and measuring it. These are potential metrics. There are others, but these are some really common ones. Now, I mentioned earlier something called a key performance indicator or KPI. KPIs come from David Parmenter, and he's got a few ways of describing them. He says a key performance indicator for business, number one, should be non-financial. So not just the bottom line, but something else that might be associated with it or that measures the overall productivity of the association. They should be timely, for instance, weekly, daily, or even constantly gathered information. They should have a CEO focus. So the senior management team are the ones who generally make the decisions that affect how the organization acts on the KPIs. They should be simple. So everybody in the organization, everybody knows what they are and knows what to do about them. They should be team-based, so teams can take joint responsibility for meeting each one of the KPIs. They should have significant impact. What that really means is they should affect more than one important outcome. So you can do profitability and market reach, or improved manufacturing time and fewer defects. And finally, an ideal KPI has a limited dark side. That means there's fewer possibilities for reinforcing the wrong behaviors and rewarding people for sort of exploiting the system. Next, there are SMART goals, where SMART stands for specific, measurable, assignable to a particular person, realistic, meaning you can actually do it with the resources you have at hand, and time bound, so you know when it can get done. So whenever you form a goal, you should try to assess it on each of these criteria. And that's a way of saying that this is a good goal to be used as a metric for the success of our organization. Now, the trick, however, is when you have multiple goals, multiple possible endpoints. And the reason that's difficult is because, well, it's easy to focus on one goal if you're just trying to maximize revenue, or if you're just trying to maximize, graduation rate. There's a lot of things you can do. It becomes more difficult when you have to focus on many things simultaneously, especially because some of these goals may conflict. The things that you do to maximize one may impair the other. And so when that happens, you actually need to start engaging in a deliberate process of optimization. You need to optimize. And there are ways that you can do this. If you have enough data, you can do mathematical optimization to find the ideal balance of efforts to pursue one goal and the other goal at the same time. Now, this is a very general summary, and let me finish with this. In sum, metrics or methods for measuring can help awareness of how well your organization is functioning and how well you're reaching your goals. There are many different methods available for defining success and measuring progress towards those things. The trick, however, comes when you have to balance efforts to reach multiple goals simultaneously, which can bring in the need for things like optimization. When talking about data sourcing and measurement, one very important issue has to do with the accuracy of your measurements. The idea here is that you don't want to have to throw away all your ideas. You don't want to waste effort. One way of doing this in a very quantitative fashion is to make a classification table. So what that looks like is this. You talk about, for instance, positive results, negative results. And in fact, let's start by looking at the top here. The middle two columns here talk about whether an event is present, whether your house is on fire, whether a sale occurs, whether you've got a tax evader, whatever. So that's whether a particular thing is actually happening or not. On the left here is whether the test or the indicator suggests that a thing is or is not happening. And then you have these combinations of true positives, where the test says it's happening and it really is, and false positive, where the test says it's happening but it's not. And then below that, true negatives, where the test says it isn't happening and that's correct. And then false negatives, where the test says there's nothing going on, but there is in fact the event occurring. And then you start to get the column totals, the total number of events present or absent, and the row totals that talk about the test results. Now, from this table, what you get is 4 kinds of accuracy, or really 4 different ways of quantifying accuracy using different standards. And they go by these names: sensitivity, specificity, positive predictive value, and negative predictive value. I'll show you very briefly how each of them works. Sensitivity can be expressed this way. If there's a fire, does the alarm ring? You want that to happen. And so that's a matter of looking at the true positives and dividing that by the total number of alarms. So the test positive means there's an alarm, and the event present means there's a fire. You want always to have an alarm when there's a fire. Specificity, on the other hand, is sort of the flip side of this. If there isn't a fire, does the alarm stay quiet? This is where you're looking at the ratio of true negatives to total absent events, where there's no fire and the alarm's not ringing, and that's what you want. Now, those are looking at columns. You can also go sideways across rows. So the first one there is positive predictive value, often just abbreviated as PPV. And we flip around the order a little bit. This one says, if the alarm rings, was there a fire? So now you're looking at the true positives and dividing it by the total number of positives. Total number of positives is any time the alarm rings. True positives is because there was a fire. And negative predictive value, or NPV, says if the alarm doesn't ring, does that in fact mean that there is no fire? Well, here you're looking at true negatives and dividing it by total negatives the time that it doesn't ring. And again, you want to maximize that so the true negatives account for all of the negatives, the same way you want the true positives to account for all of the positives, and so on. Now, you can put numbers on all of these going from 0% to 100%, and the idea is to maximize each one as much as you can. So in sum, from these tables, we get 4 kinds of accuracy, and there's a different focus for each one, but the same overall goal. You want to identify the true positives and true negatives and avoid the false positives and false negatives. And this is one way of putting numbers on, an index really, on the accuracy of your measurement. Now, data sourcing may seem like a very quantitative topic, especially when we're talking about measurement, but I want to measure one important thing here, and that is the social context of measurement. The idea here really is that people are people, and they all have their own goals and they're going their own ways, and we all have our own thoughts and feelings that don't always coincide with each other, and this can affect measurement. And so, for instance, when you're trying to define your goals and you're trying to maximize them, you want to look at things like, for instance, the business model. An organization's business model, the way they conduct their business, the way they make their money, is tied to its identity and its reason to be. And if you make a recommendation that's contrary to their business model, that can actually be perceived as a threat to their core identity, and people tend to get freaked out in that situation. Also, restrictions. So for instance, there may be laws, policies, and common practices, both organizationally and culturally, that may limit the ways that goals can be met. Now, most of these make a lot of sense. So the idea is you can't just do anything you want. You need to have these constraints. And when you make your recommendations, maybe you'll work creatively in them as long as you're still behaving legally and ethically. But you do need to be aware of these constraints. Next is the environment. And the idea here is that competition occurs both between organizations. That company here is trying to reach a goal, but they're competing with company B over there. But probably even more significantly, there is competition within the organization. This is really a recognition of office politics, and that when you as a consultant make a recommendation based on your analysis, you need to understand you're kind of dropping a little football into the office, and things are going to further one person's career, maybe to the detriment of another. And in order for your recommendations to have the maximum effectiveness, they need to play out well in the office. That's something that you need to be aware of as you're making your recommendations. Finally, there's the issue of manipulation. And a sad truism about people is that any reward system at all, will be exploited, and people will generally game the system. This happens especially when you have a strong cutoff. You need to get at least 80% or you get fired. And people will do anything to make their numbers appear to be 80%. This happens an awful lot when you look at executive compensation systems. It looks a lot when you have very high stakes school testing. It happens in an enormous number of situations. And so you need to be aware of the risk of exploitation and gaming. Now, don't think then that all is lost. Don't give up. You can still do really wonderful assessment. You can get good metrics. Just be aware of these particular issues and be sensitive to them as you both conduct your research and as you make your recommendations. So, in sum, social factors affect goals, and they affect the way that you meet those goals. There are limits and consequences both on how you reach the goals and how really what the goal should be. And that when you're making advice on how to reach those goals, please be sensitive to how things play out with metrics and how people will adapt their behavior to meet the goals. That way, you can make something that's more likely to be implemented the way you meant and more likely to predict accurately what can happen with your goals. When it comes to data sourcing, obviously the most important thing is to get data, but the easiest way to do that, at least in theory, is to use existing data. Think of it as going to the bookshelf and getting the data that you have right there at hand. Now, there's a few different ways to do this. You can get in-house data, you can get open data, and you can get third-party data. Another nice way to think of that is proprietary, public, and purchased data, the 3Ps I've heard it called. Let's talk about each of these a little bit more. So in-house data, that's stuff that's already in your organization. What's nice about that is it can be really fast and easy. It's right there. And the format may be appropriate for the kind of software and the computer that you're using. If you're fortunate, there's good documentation, although sometimes when it's in-house, people just kind of throw it together. So you have to watch out for that. And there's the issue of quality control. Now, this is true with any kind of data, but you need to pay attention with in-house because you don't know the circumstances necessarily under which people gathered the data and how much attention they were paying to something. There's also an issue of restrictions. There may be some data that while it's in-house, you may not be allowed to use, or you may not be able to publish the results or share the results with other people. So these are things that you need to think about when you're going to use in-house data in terms of how can you use it to facilitate your data science projects. Specifically, there are a few pros and cons. In-house data, potentially quick, easy, free. Hopefully it's standardized. Maybe even the original team that conducted this study is still there. And you might have identifiers in the data which make it easier for you to do an individual level analysis. On the con side, however, the in-house data simply may not exist. Maybe it's just not there. Or the documentation may be inadequate. And of course, the quality may be uncertain. It's always true, but maybe something you have to pay more attention to when you're using in-house data. Now, another choice is open data, like going to the library and getting something. This is prepared data that's freely available. It consists of things like government data and corporate data and scientific data from a number of sources. Let me show you some of my favorite open data sources, just so you know where they are and that they exist. Probably the best one is data.gov here in the US. That is it says right here, the home of the US government's open data. Or you may have a state level one. For instance, I'm in Utah and we have data.utah.gov, also a great source of more regional information. If you're in Europe, you have open-data.europa.eu, the European Union Open Data Portal. And then there are major nonprofit organizations. So the UN has unicef.org/statistics for their statistical and monitoring data. The World Health Organization has the Global Health Observatory at who.int/GHO. And then there are private organizations that work in the public interest, such as the Pew Research Center, which shares a lot of its data sets, and the New York Times, which makes it possible to use APIs to access a huge amount of the data of things they've published over a huge time span. And then two of the mother loads, there's Google, which at google.com has public data, which is a wonderful thing. And then Amazon at aws.amazon.com datasets has gargantuan datasets. So if you needed a dataset that was like 5 terabytes in size, this is the place that you would go to get it. Now, there's some pros and cons to using this kind of open data. First is that you can get very valuable datasets that maybe cost millions of dollars to gather and to process. And you can get a very wide range of topics and times and groups of people and so on. And often the data is very well formatted and well documented. There are, however, a few cons. Sometimes there's biased samples. Say, for instance, you only get people who have internet access, and that can mean, not everybody. Sometimes the meaning of the data is not clear, or it may not mean exactly what you want it to. A potential problem is that sometimes you may need to share your analyses. And if you're doing proprietary research, well, it's going to have to be open research instead. And so that can create a crimp with some of your clients. And then finally, there are issues with privacy and confidentiality. And in public data, that usually means that the identifiers are not there, and you're going to have to work at a larger aggregate level of measurement. Another option is to use data from a third party. These go by the name Data as a Service, or DAS. You can also call them data brokers. And the thing about data brokers is they can give you an enormous amount of data on many different topics. Plus, they can save you some time and effort by actually doing some of the processing for you. And that can include things like consumer behaviors and preferences. They can get contact information. They can do marketing, identity, and finances. There's a lot of things. There's a number of data brokers around. Here's a few of them. Axiom is probably the biggest one in terms of marketing data. There's also Nielsen, which provides data primarily for media consumption.